Okay. तो हमने रिवर्सिबल रिएक्शन कंप्लीट किया था और उसके पास पेपर क्वेश्चंस वी डिस्कस्ड इट इन द लास्ट क्लास. Do the Haber process. Let's look in contact process. Basically, it is the industrial preparation for ammonia. In industries, ammonia is actually prepared on a large scale by contact process. And in the contact process, this chemical reaction occurs where nitrogen gas and hydrogen gas both allowed to react with each other to form ammonia. And if you see the sign, this indicates that the reaction is reversible. And then if you look at the enthalpy change, what is the value of enthalpy change?
Minus
Yes,
92.1.
Yes, it's a Haber
Kilojoules.
process. Yes, what is the value of enthalpy change? Negative 92.1. What does a negative sign indicates?
Exothermic.
Which reaction is it? Exothermic reaction it is. Okay. Now you must know that from where we got these two reactants or the raw material, nitrogen is obtained from the air. We do the fractional distillation of air to separate nitrogen from it. And from methane, we obtain a hydrogen gas by cracking methane. Okay. Now, if we have to get the maximum yield, if you see the reaction is exothermic. So we did discuss in the last class, when we increase the temperature, the reaction occurs in the endothermic side. And when we decrease the temperature, the reaction goes towards the exothermic side. So the delta H is negative 92.1, which indicates that the forward reaction is exo. So it means we need a lower temperature. And if you look at the moles on the reactant side, how many moles of gases are there? 4. 1 mole of nitrogen and 3 moles of hydrogen. So there are 4 moles. And on the product side, how many moles are there? 2 moles. 2. So it means that the product side has a lesser mole. So if we want to make more product, we need a higher pressure. So to get the maximum yield of ammonia, we need a higher pressure to be maintained and lower temperature to be maintained according to the Leach-Ateliers principle. Okay, but in industry, when this reaction is performed, we actually maintained a higher pressure. See, it's 20,000 kilopascal. See, we are maintaining a higher temperature, higher pressure, but also we are maintaining the higher temperature as well. But according to the Leach-Ateliers principles, we need a lower temperature, but we are not maintaining the lower temperature, but we are maintaining a moderate or a little higher temperature, which is 50 degrees Celsius. And beside this, we are using iron as a catalyst, which is speeds up the reaction. So see, as we are not using the low temperature, we are using the high temperature instead. That's why we are considering it as compromising temperature. We actually compromising on the temperature condition. Also, we need a lower temperature to get the maximum yield, but we are not maintaining the lower temperature, but we are maintaining a little higher. So that's a compromising temperature. That's why we are saying it's compromising. Is this understandable to all of you?
Yes, sir.
Okay, just complete this, and I will going to explain that why we are compromising on the temperature. I will explain it. First, complete this quickly. If anyone of you has any confusion, you can ask, please.
Sir? Hello?
Yeah, you can say that it's basically the application of a reversible reaction. Is everybody done?
Yes, sir.
Yes, everyone done? Yes, Rohit? Okay. Now, why we are using compromising temperature? Okay, just give me a minute. Okay. So it is because at lower temperature, what happens to the rate? The rate or the speed of the reaction would decrease and it slows down. So obviously we will get a higher amount of ammonia, but that higher amount of ammonia would be formed in the longer time because the rate is slower due to a lower temperature. And as a result, more energy is used up. So that's why for industries, the process to perform the process at a lower temperature is not feasible economically. It will cost them a lot. So that's why they have maintained a for 50 degrees Celsius temperature, a little higher or a moderate temperature, and they compromise on it. So the rate would be, the rate of the reaction would stay faster. And how they overcome on that compromising temperature? As soon as the equilibrium establishes, and what we know that when the equilibrium establishes, what will happen? Further reaction stop. So what will do? They will condense ammonia, and as a result, they remove the ammonia from the container in which it is formed. So as soon as the ammonia would, remove from the container, the equilibrium again shift to the right, and reactants start turning into the product again. And when the equilibrium establishes, the ammonia would again remove. So that's how they overcome the yield, and they can maximize the yield by this way.
टेम्परेचर से यील्ड पे फर्क नहीं पड़ता?
Is everybody done? Okay. Now we have almost in the whole world almost 80% of the ammonia is used to make fertilizers. Ammonia is further used to prepare nitric acid and explosives. Further, you must remember that all the salts which contains ammonium ions and nitrate ions, any salt or any compound having these two ions or either any one of the ions from these are we prepare ammonia we will be discussing O levels as well. Oh, sorry, accident is as well. It will sort as well. Complete this quickly. Beside nitrogen, the compounds contain phosphorus and potassium. Used also does more than class, which includes nitrogen, phosphorus, potassium. Called any fertilizer because fertilizers contain any of the element from these. That's why fertilizers are prepared in